Equiangular triangle means we are familiar with the congruence of triangles. Okay, congruence means all three sides and all three angles are equal between two different triangles. That's called as congruence between triangles. Equiangular triangles concept also like that, but no, not exactly same as the congruence. Equiangular, here we are only concerning about the angulars. It doesn't mean if all the angles of a triangle is equal to another triangle, it doesn't mean both of them are same. There are many uh, dissimilarities as well. Look at this. This is a triangle. I will draw this triangle. Okay. The angles contention, this is 70 degrees and this would be 40 degrees and no, not 40. I'll make it as 50. Next one is 60. Okay. There are three angles. By using the same angles, we can produce a triangle like this. Okay, a triangle like this. So from here, you have to understand the main concept here. This is not congruence. If those two are equiangular triangle means that doesn't mean all the sides are same with each triangle. Only the angles, only the particular inclined angles are similar with two triangles. And the concept is if these two are equiangular triangle, their corresponding sides are in same ratio. Their corresponding sides are in same ratio of length. For an example, here I will mark A, B. See, this is PQR. Let's analyze these two triangles. Now we got satisfied these two are equiangular triangles because all three angles in this triangle are same with the exact all three angles with another triangle. Now come to here. The ratio between corresponding side means in between 70 degree and 50 degree you will have AB. In between 70 degree and 50 degree, you will have PQ in next triangle. So, AB upon PQ, AB upon PQ, it should be equals to, let's come to the next one. The side which is located in between 70 degree and 60 degree in the small triangle, 70 degree and 60 degree in the larger triangle. So, these two are also same. AC upon PR, not the length are same, the ratio. Third one, this should be equals to the third side in between 50 degree and 60 degree, the included side 50 and 60. BC upon QR. This is what called as equiangular triangle theorem. All three angles of a triangle equals to another triangle's all three angles. So it doesn't mean those two are congruent. From that we can determine the relationship between them. This particular side, okay, this particular side divided by this one exactly equals to this one divided by this and this one divided by this. Make sure you are writing the same order. The smallest triangle side should be located in the numerator and larger triangles length should be denoted in the denominator. So this is equals to a constant value. Always this value is same. In equiangular triangle, always these values are same. We cannot predict is it 1 or 2 or 5 like that, but all the ratios between the corresponding included sides are same. That's all for the T. The first triangle, this is an equiangular triangle. Look at this. Because in the same slope, this is located. Inside this, the same slope, with the same slope, this is located. For an additional information, I will make it as parallel. Mostly students will got confused whether it is midpoint theorem. Here we need to apply midpoint theorem or either equiangular triangle. So look at this. In midpoint theorem, definitely you need a data that whether it is a midpoint or not. If it is a midpoint or not, you can in any occurrence you can use the equiangular triangle theorem. So you have to Interpret the data to understand whether it is equiangular triangle or midpoint theorem. In midpoint theorem case, they will clearly mention it is a particular midpoint or the total length is bisected likewise. In equiangular triangle, nothing needed like that. Look at here. So oh sorry for that. So here let's make it as 9 centimeter. So here I will make this one as 9 point, sorry, previously I made a mistake. So it would be 14 point 13.8 centimeters. Okay. First, look at the sides in both. This is an equiangular triangle of since this is parallel. This is a common angle belongs to both triangle, the small triangle and the larger triangle. And thereafter, look at these two. Since these are parallel, the corresponding angles are same. This and this same, this and this same. So from that, we concluded this as an equiangular triangle. Then I'll write the equiangular ratio confirmation. So I will write the ratio between two known corresponding sides. This 9 and 18. From the small triangle 9 centimeter, from the big triangle 18 centimeter. 9 divided by 18. It should be equals to, in the next triangle, next side, sorry. In the next side, look at here. In the small triangle, this side. In the larger triangle, the larger side. 2.5 upon z. 2.5 upon z. And next one, in the small triangle y, in larger triangle 14. Y and 14. You can use any two formulas, any two equations to solve for z. Solve for z. So when you use these two fractions to solve for z, you can get z as 5 centimeter. Because what is the relationship between them? 9 became 18. So likewise here, if the ratios are same, 2.5, that will become double of it. Z would be 5 centimeters. Z would be 5 centimeter. Here also, the larger length is 14. So the smaller length would be half of it. Y is equals to 7 centimeter. I'll repeat it again. Try to analyze the ratio. Here it became a double of it. Numerator to denominator. 9 multiplied with 2, 18. So 2.5 multiplied with 2, Z is 5. And in opposite, 18 to 9, let's go. 18 divided by 2, 9. Likewise, 14 divided by 2 will give you y as 7 centimeters. Y as 7 centimeters. That's all for the first question. Likewise, we need to do for the next question as well. These are the known two sides, this one and this one. By using that, we have to construct a relationship. So in the small triangle, I will mark this length and this length. 4.6 upon 13.8, that should be equals to this 9.7 in small triangle, in largest triangle h. 9.7 upon h. In the next triangle, here, this is f and 15. Make it as a centimeter measurement. F upon 15. Let's find the relationship between them. What is happened here was 4.6 multiplied by 3, that will give you 13.8. Likewise, to find the length for h, you need to multiply 9.7 times into 3. So that will give you 9 into 3, 27. 3 into 3, 21. So 29.1 centimeters. That is the length for h. 29.7 centimeters. 1 centimeter, and here it is 15. 15 to f, you need to divide this by number 3. So f would be 5 centimeters. If not, if you want to solve this, you can solve whatever method which you know, but this is the simpler one. Look at the ratio between denominator to numerator. If you need the denominator, multiply. If you need the numerator, divide it to finalize your answer. That's all from the equiangular triangle.